I continue to work on the compiler for the Elna programming language. The compiler is self-hosted and written in itself. Therefore, we can currently only use basic features that are already implemented. And today I'm going to start implementing so-called type traits. So the current state is that each record structure automatically generates a function with a size suffix, and this function returns the size of the data type in bytes. But it is only a temporary solution. Actually, what I want to have are special kind of compile time functions that can tell me some information about the type system. And these functions, these compile time functions, have almost the same syntax as normal call expressions. But the name of a trait starts with a hash sign. So basically it looks like this. And the arguments are not normal expression but type expressions, so that I can write size and then a type name or type expression, and this thing should return me the size of the type. We will begin just with supporting simple types, so just a type name, but actually these type traits should be able to accept any type expression, like a pointer type, for example. So it's almost the same as the size of operator, but C defines multiple operators like size of, line of, and I want to have a special syntax for this kind of things that can support these situations where we need to get some information from the compiler about a type expression. And the first thing that we need to extend is actually the lexer. I have a table-based lexer, and we need to find the place where the table is generated. Or first we need to look whether we already have a token for these traits. So I think an Alexa class, we probably this is a character class, so all characters are split into classes, so the tables are a bit shorter. Alexa state, Alexa kind is the thing that we want, and here I do not see anything that looks like trait. Okay, we have trait kind, so we have already a type here. Then we will need character class for a trait, so hash valid digit alpha space colon equals asterisk backslash. Why is backslash a separate class? Probably for escaping. Single hex 0 x off dot. This is for operators, for quads and others. So let us set hashing here. Interesting to see whether it will break something. Yeah, it does. If I put it as the last thing, then it works. So I use somewhere a number instead of enumeration. Okay, the order doesn't matter actually. And this is the place, I think, where we assign a class to each character. Yes. So we only support currently the ASCII characters, the 7-bit ones. And the first thing I need to look for an ASCII table. And this is the code 35. So the first symbol E off has the code 1. E off means that we stop here. They are actually invalid. Space class. Something double quote is 35. But it has the code 34. That means that the characters are moved by 1 because our arrays are 1 based and not 0 based. So actually the next character after the double quote is, let us call it officially a number sign. So I also fix it here and we call it number sign. Okay. We probably need 2 states. One for the start of the lexeme, so when we encounter the number sign, and one where we are in the middle of that process. Basically, the tokenizing will be almost the same as for an identifier, but we have to look that the first thing is a number sign. we will need at least one new state. Let us call it number sign as well, and probably we will need another one for the trait. Not sure yet. Okay, at least this doesn't break anything. So we have here state for an identifier, and let us look where it is used. Identifier, and here we have state transitions. So state transitions describe how I go from one state, for example start state, if I encounter a specific thing, what action should I do, and what would be the next state on this character. Exactly, this is identifier state. And I think that we can just copy it. We need to extend the array somewhere, because these states are saved in a global variable, and we probably need to so their state in this static part of the file, and the storage for this table probably should be extended. As I see here, currently the states are not in order anyway. Escape sequence string, and then we put the number string here. Number sign state. So this is the state that we describe, so it is number sign state. Yeah. But here we have a different problem. We do not have a semicolon here. Okay. So by default, if we are in the number sign state, yeah, I should have a second state here. So we probably need a trait state as well. And we copy these once again for the next state. Oops, this is trait, and trait. So by default, default, we finish the trait tokenizing, the trait name tokenizing. If we are in number sign state and we encounter a digit, probably they shouldn't be allowed to start with the digit. It doesn't matter, actually. We do not need it, we handle them by default. So if we see an alpha, so a character, then we do the accumulate action and we switch to the trait state. So currently we encountered just a number sign, and we describe how we change the state if we meet the next character in the sequence in the source code, and this should be trait. So if we see a hex digit means A to F, and we go to the trait state in this case. If we see a 0, this is an error as well, and if we see an X, then we go to the trait state. So now we are in the trait state. In the trait state, if we see a digit, then we remain in the trait state and accumulate, so save the characters. The same goes for alpha and actually for everything else. That should be it. Now we need to go to the beginning of this table because it will define. So here we see the transitions from the start of the token, and here we say that we want to describe a transition from the start. If we see a character number sign, then actually we do not need any action, we can just keep the sign, or we accumulate it at first, accumulate, and we go to the state number sign, and after that the other state descriptions will do their job. So that is here. I'm thinking whether I need something else. So if we just see something else after the name, then we finish the token, and this is actually enough. I'm a bit suspicious because I had some calculation somewhere where the size of this tables is calculated, and this is actually here. So each state is 8 bytes long, towards action and next state. There are 22 character classes. So this and we just added an additional character class, so we do have one more now. That means that we need to multiply, say that there are 23 character classes, 23, and that would be 184. Okay, that fine as it seems. I'll get transition. State size hasn't changed. We still have only 256 characters, but we extended in another table. We extended this state table as well. So Lexer state is saved after the transition table. Each transition table entry is 8 bytes long. The table has 60 rows and 22 columns. And now we have 2 more states, 2 more rows, and 1 more column, I think. So it would mean that then we I think not 16 but 17. So we now have 23 columns and 19 rows, and we need to multiply it. And then we have 3, 4, 9, 6. So normal arrays aren't available yet, and therefore I need to use a chunk of memory and just put data in there. So there is some need, unfortunately, to calculate these offsets, so we can pack these tables into memory. But I think that is for the tokenizer. We cannot use the type traits in this compiler stage because the previous version of the compiler won't be able to compile these traits, so we need to create a new stage, so the next version, because and because we just continue to work in this stage, and we also want these changes in the next stage, and we want to do the same work twice, so we go to the rake file that I use for the compilation, and I had somewhere code. So we are now in stage 17, and we want automatically create a stage 18 and copy it from the stage 17. We do not need this thing anymore. I actually think that we can just remove this stuff. Current state. Okay. So we want to save our current changes, so we can revert if needed. This is stage 17, and we want to make the first copy, so we copy the stage 17 into the stage 18. Rake will automatically pick it up and compile in additional stage. And let us use this thing somewhere. So we just wrote the tokenizer for this hashtag size. The rest of the expression, so the parentheses and the arguments, this is something that the parser will handle. And it crashes. But well, the tokenizer cannot do anything with this. Somewhere actually just keep semicolons. It gets compiled this way. I have almost no error checking currently, and after parsing a statement, the parser keeps a token, and normally this token should be a semicolon, but since I do not check what token it is, it just skips a random token, and in this case it skips the whole hashtag size. This verifies for us that the thread name is tokenized correctly, so that the parser sees the whole size, this thread name as a single token, as it should be. So we already know that works as expected. And the next thing that should be extended is the parser. And actually we are going to extend the kinds again, but this time not the Lexa kind, but the tree kind. Probably I already have a trait expression here. No, I do not. To read kind, and we need a new. This is actually, let us call it trait expression, I suppose. Now we also need a data structure to say this expression. It actually pretty similar to the procedure call, but we make it a bit simpler at first and just allow a single argument. It seems that I have the records for the expressions above. Yes, exactly. Elnode type, Elnode retype, and here we have the expressions. Elnode 3 array type expression. Is it used anywhere? I already implemented some code that does the array parsing, but they are not supported then generating the code. So we can just add a trait expression here. We call it a trait expression. It is a record. It will have the expression kind as its first argument. So what we have else? Each trait has a name and name length, so we do not have strings yet, so we save the name pointer and the name length separately into fields, and we call one name and the another one length. And the last thing would be actually the list of arguments. As said, I'm currently interested only in this size of operation, so it has only one argument. And we can just call it argument of type word. Actually, it will be a type expression. Probably we can just save the name. I don't know if I want to save the type would be better. So or we can call it type expression. Okay, that's fine. So we have a type for these expressions. Basically, the next place would be the parser then. So we can remove this again, and we need the parser functions. Let us see where the character literal used, for example, parser character literal. This is a simple expression. So simple expression is a literal or an identifier. Actually, we can recognize a trait here already. The next, so parser simple expression, where it is used in the designator, parser, and here. But a trait is actually not a designator. Neither a procedure call, but we handle here the procedure calls, and we can handle here the type traits. Why is it called token kind 1? The difference is that these designate expressions, they can follow each other. So for example, a pointer, we have a pointer, then we have a pointer dereferencing, pointer dereferencing, pointer dereferencing. So you can actually stack multiple designators, and the same is valid for the procedure call. So we can call a procedure, and this procedure can return another procedure. So it is possible to call another procedure as well. Therefore, it is designator, but it is different, of course, for these type traits, because if we have a type trait won't return anything that can be called again. So we handle them in the simple expression. I think it is more a simple expression than a designator. Simple expression. Okay. So this is TC. This is not what we need. We need the parser simple expression. It was here. And we will define a new procedure here, and parser trait expression. And we will call it here. So if the thing that we see is how is it called? It was trait name. Then we say that the parser node is elna parser trait expression. So that is fine. let us look for another, for example, what is pretty easy. Elna parsing integer literal parsing should be pretty easy. So it just creates a new data struct or data element. So we need a result variable of type word. Actually it will be elna3 trait expression, and we will return this thing as result. And the first thing would be to allocate the memory for this thing. So trait expression size trait expression size return result. This is of course the wrong version. We have to edit. This is the 18th stage and this is the 17th. So we remove this one from here and go to the Elna parse simple expression here. And then we remove this else if from here and put it in here. Looks better. I also changed the name of this token kind thing. Okay, and then we have here this result one. That can be called just result. Nope. So now we have this parser thread expression function. So we allocate the data structure, and currently we are looking at the name of the thread. So we will need token kind. Something similar should be done for the assignment statement, because we need an identifier there, and now actually it is not an identifier. We have two expressions on both sides. What is with procedure call? Parser call maybe. So exactly, we need to assign the kind of the variable. So we say that result is of the kind elna3 kind trait. Was it just trait? Probably elna3 kind. This Alexa kind. It was probably trait expression or nothing at all. Yeah, trait expression it is. So it is a trait expression. Okay. I was looking at the call parser, because exactly it sets the next element, because the next elements are assigned later. We can set the result next. No, we cannot. This is an expression. A call is a different thing, because it is a statement. Statement is a list where you have basically the next statement in the list, but it doesn't. It is not needed for the expressions. And here we read a token, left parent if right parent, set call name result and callee. Call parts expression. Yeah, that was it. Actually, I think that I can just call this function first, because the parser should point to the name of the trait. So we just get the start of the current token from the tokenizer, and we need to assign it to some variable, actually to the result name. And the result length would be the same, so we say that the result length is an Alexa global get end minus the the start of the token, so minus result name. It seems to work, and now we need to skip one token, so we need to skip the current token and then the open parent, so we need a new variable named token kind, and we skip the current token with Elena Alexa skip token. And then we read the next token, and then we can skip it as well, because it will be just an opening parent. So we can skip it as well. And we have to read the next token. The next token will be a type name, and at this point we can pass type expression, and we have a procedure for this thing, and we are going just to call this procedure, so it is result argument is in parser type expression. After that we have to read the closing parent, and we skip it, and then we can exit the procedure. Okay, that looks fine. Let us copy this stuff to the stage 18, so we do rake convert. We read this file and just let us say we say that offset is size of something. We need a real type expression, for example, alphabet. And it says undefined reference to what? What is with Elna3 node? Undefined reference to Elna3 node. And this is in build boot stage 18. Okay, generates a lot address instruction. I suppose this is at least not a call. But well, we do not handle them. The next pass of the compiler is 3 address code generation. So let us look into the generation for the simple expressions, because it will list all possible variants. This is probably the reason, because I check the types, but here I do not check the type and just assume that if this is not some literal, then it is basically a variable expression, and of course it is not. And verify it tries to load this thing, the address of this thing, because it thinks it is a global variable. So let us check whether the parser node kind is Elna3 kind trait. Then okay, it will crash because the instruction variable will contain garbage. Would be pretty interesting if we just generate something. Let us just generate 0 for it, just as placeholder, just as a placeholder. And of course the name is Ron. Okay, we compiled the 17th stage. When if we copy it into the next stage and try again, then it can be compiled as it seems. And let us look into the generated assembly. So stage 18, and we need this procedure. This is main, and one of the last instructions. I should have probably try it with the short of function, and this is the epilogue. And at the end we have an exit, but this assignment is kind of missing. Let us define a procedure. Oh, I think I haven't reloaded this file. Yes, therefore it's missing. I updated I updated the state, but haven't reloaded the source code. So once again, and then we reload this thing, and then we just add a new procedure. Let us call it F, and everything it does, it just returns the size of something. For example, the size of what? And probably the same will be the case for other things, like, I don't know, Elena instruction list. Okay, that doesn't seem to work. I think that the parsing is probably wrong. I had a printf statement somewhere for debugging. No. Let us go into the parser of this trait. So it was parser trait expression, and we will try to print a comment here just to see if we go into this procedure. So basically we just at the beginning we will I shouldn't have removed this one, so we will just put a printf statement with a comment and new line and 0 terminating character, and we will compile it again. This is the 17th state. I have a comment. Okay. Where does it fails actually? build boot stage 17, build boot stage 17 CL. I think it can be because of the hash sign, this number sign. So I have a hash as part of a string. So let us look at the tokenizer. We go to this stage 17 again. And let us search for the number sign, and we have a state to parse a string somewhere at the bottom. I think this is here for comments. So for comments we do use comment as default state and define some characters that cause invalid state. But for the strings, identify state, count state, decimal leading 0, greater state minus left less comments character. So here we do have string state, and here we do actually define, so the default state is also the string state. I haven't extended this Alien Lexo default transition procedure. Lexo default transition. Let us find it. Yes. So it just sets all possible state transition to a default action and to the next state. So it just should list all of the available states. Let me look at the list of the states once again. Entry statement, no, not statement. Lexa class, these are the states. So it begins with no, it also gets the status parameter, but it sets a state for all character classes, and we have added the character classes as well. So it starts with invalid, digit, alpha, and then it goes to the other, and after other follows the number sign. Okay, this is stage 17. This is stage 17, and I haven't removed this printf. So the code compiles, and that would mean that we can compile number signs inside strings, not compile, tokenize, to be precise. Yes, that compiles now, and if I look into the assembly, for example, build boot stage 18, and here we do not see anything as well. But we will have to look into this next time. So we extended the tokenizer and the parser to be able to parse this new construct, these trait type expressions, and we just need to fix a few things here and there, but the compilation as well, so the translation of this trait type expression will be pretty easy, I hope, because we have the most things in place, and we have already a similar thing that we are going to replace, so these automatically generated procedures. And the generation assumes just that we find the type, the size of the type, and that we replace this trait type with the type size, probably somewhere after the type analysis during free address code generation, or somewhere after we have collected the type information from the source code. And we will end it here and finish it next time.